Okay, for this lesson, we are doing lesson 3.3, function notation. Oh, this book is stuck. So, somebody tell me what the definition for function notation says. You just wrote it. Yes, ma'am.
Another name for...
Can I say?
Yeah.
Sure.
Another name for y denoted as f times x and read as the value of f at x or f of x.
Good. So when you see that letter, I know I'm frozen on here. Hopefully I'm not really actually frozen. So when you see this f and then parentheses x, you read that as f of x. So the parentheses mean of, which also means times in our mathematical world, but you read it as f of x. You have a normal equation, y equals 5x plus 2. Function notation is just the function of x, f of x, is 5x plus 2. Think of this as another label. Don't think of it as something you have to solve, the f of x. It's a label like y. Y is a label, correct? Mm-hmm. Okay, so there's nothing to solve there. You're solving everything over on the right. Okay?
Yes, sir.
All right. So let's go look at... So you know that a linear function can be written in our slope-intercept form, correct? What is slope-intercept form?
Y equals mx plus 4.
Very good. And all they did was change the y to f of x. You're going to eventually see g of x or all kinds of other ways that they label it. Let us do example 1. So it tells you evaluate f of x equals negative 4x plus 7 when x equals 2 and when x equals negative 2. So we're going to solve this function 2 times. So all you do is write the function. Go ahead and write this in your journals. Example 1. And then it told us to do x equals what?
Negative 4x. Oh, wait. Oh, 2 and negative 2.
Okay, so let's solve it with 2. So we're going to replace the x with the number 2. So when we do... All right, so when you plug in the function of 2 into where x is, you have negative 4 times 2 plus 7. What is negative 4 times 2?
Negative 8.
Positive 8. Oh, wait. No. Negative 8.
Negative 8. And then plus 7?
Negative 1.
Very good. I'm trying to recast. So then f of x equals negative 1. But we also have to solve the other side. So for solving for 2, now we're going to solve for negative 2. So you plug in negative 2. What's negative 4 times negative 2?
Positive 8.
Positive 8 plus 7 is?
15.
Very good. 15. So when x equals 2, the function of x is negative 1. And when x equals negative 2, the function of x is 15. Any questions? Yes?
How would we write the answer in the book?
You can do f of 2 like this, equals negative 1, and f of negative 2 equals 15. I don't need you to write out this whole sentence. Does that help?
Yeah.
Good. Any other questions? All right. All right. Example 2. Put this in your journals. So let the function of t be the outside temperature in Fahrenheit, t hours after 6 a.m. Explain the meaning of each statement. So if we have the function of 0, first of all, what is t standing for?
Outside temperature. Hours after 6 a.m.
It's the hours. T equals time. So it's the hours after 6 a.m. So if the function of t, if f of t, the t is 0, what time is it? No?
6 a.m.
6 a.m.
Oh,
The beginning time. 6
yeah.
a.m. So the function of 0, 58 is what?
The temperature
at
out there.
at 6 a.m.
Oh, yeah.
Yeah, so it's 58 degrees at 6 a.m. So the function of 6 would be, what's the function of 6? Well, what does the 6 represent?
Time.
6 hours after what?
6 a.m.
6 a.m. Very good. So 6 hours after 6 a.m., we have the time or the temperature of N. Right? We don't know what the temperature is. But at noon, it's N. Right?
Yes.
So far, so good? What about C? We have the function of 3, and it says it's less than the function of 9. So what is that telling us?
That it's
It's older, earlier.
It's colder. Sure. But what times?
3.
Closer to
3 hours after 6 would be
9,
9 a.m. And then 9 hours after 6 would be
3.
3 p.m. So at 9 a.m., it is colder than 3 p.m.
What?
that makes sense.
I doesn't.
So the temperature at 9 a.m. is less than the temperature at 3 p.m. Okay?
Yes.
Do all those things make sense?
Yes.
Why do we look confused?
I'm just tired.
Okay, you're allowed to be tired.
Write all of that.
You can shorthand it, right? Just enough to make it make sense to you. I will pause the video so you can do that. All right, so after you have written the example, go do the monitoring progress. Should be. Let's look at example 3. All right, so you see they used a different function label, h of x. Again, it's the same premise, it's the label. So find the value of x for which h of x when it equals -7. So what are we going to do with that -7? Put it wherever the x is. So write this in your journals. So
It's for the entire h of x, not just
right, in this case, for the value of x for which h of x equals -7. So in this sentence, they're telling you that the h of x, the label, equals -7. So it's like saying the y value equals -7. So you're going to plug in -7 at the beginning instead of plugging in it where the x is. I apologize, I misspoke. Now, can we solve for x?
Yes.
What's the first thing we would do?
Plus 5 to both sides.
Correct. Move 5 to the other side. So -7 plus 5 is? -2. And then how do we solve for x here?
You multiply 3 over 2 by both sides.
Yep, divide by the fraction, which is flip it and multiply.
Which is 3 equals x.
Correct, -3. Don't forget it's a -3. So when x is -3, we get h of x equals -7. You can just put x equals -3 in your answer, by the way. So it's real important you pay attention to how they're wording the sentence. In this case, it said find the value of x when h of x equals -7. So you know you're solving for x. So you're going to plug in the -7 where the h of x went. All right?
Uh-huh.
I'm guessing monitoring progress is up.
No, it's example.
Oh, example 4.
It's further.
There we go. All right, so now we're going to graph the function of x when it equals 2x plus 5. Well, first of all, looking at this, is this in slope-intercept form?
Yes.
Yes. So we can graph it. So in your journals, just, we do have to get some points. You technically don't have to get some points. All right. You don't have to get some points because that takes a long time. When it's in slope-intercept form, you just draw it. Can I write on the screen? I don't know if it'll let me.
Do we get graph paper?
No, because I'll be able to see. All right, I'm going to leave that up, but I'm going to draw it on the board. And turn my computer so you can see. So rather than making an input-output table, which you can see they just picked points on either side of 0, including 0. That's fine. But when you have the equation f of x, or y equals 2x plus 5, you have all the information you need to be able to graph it. What is the 5? It's the y-intercept specifically. So on the y line, where would I go? Up 5, because it's a positive 5. So 1, 2, 3, 4, 5. Put a dot. What's my slope?
2.
It's in front of the 2. Technically, that's a 2 over 1, right? All whole numbers are over an imaginary 1. So I go up 2 over 1, put another dot. That's your line. That's all you have to do. So you look at the slope and the y-intercept and graph it. So if you look here, they did that. I mean, they have it. So look where the y-intercept is. Where does it cross the y-line? Positive 5. Ours crossed at positive 5. Their slope was 2 over 1. They went up 2, 1, 2, over 1. Put another dot. Cool? Save you a whole lot of time than doing a chart, right? So do it that way. Get it in slope-intercept form and you can graph it. All right, any questions? Okay. Then go do monitoring progress 4 through 8. I'll leave this up so you can, but you can do what I did on the board rather than what's on the TV. All right, let's look at example 5. So this graph shows the number of miles a helicopter is from its destination after X hours on its flight. On its second flight, the helicopter travels 50 miles farther and increases its speed by 25 miles per hour. The function f of x equals 350 minus 125x represents the second flight, where f of x is the number of miles the helicopter is from its destination after X hours. Which flight takes less time? All right, so they give you the second flight, so we need to figure out the first flight by looking at the graph. You guys can see the graph, yes?
Yes, sir.
What's my y-intercept? 300. So instead of 350, you have 300. And then, can you tell what the slope is? So, changing the slope, using the slope formula. You guys remember the slope formula?
Rise over run.
Nope. Well, it is rise over run.
Y equals mx plus 3.
Nope, that's the slope intercept formula. Very good.
Fx equals.
Nope. To find the slope, you take y2 minus y1 over x2 minus x1.
What the hell are you telling me about this?
Write this down in your journals. So if I'm looking at that graph, the y-intercept is at what? 300. So x is what? 0, right? Because it crosses. So one of my points is 0, 300, right? Can you find another easy to read point on the graph?
Bottom.
Sure, yeah. So if we went x is what? 3 and y is 0. So do I have 2 points that are on this graph? Casper wanted to come in.
Yeah.
So I have 2 points on the graph now. So now can I plug them in up here?
Yes.
Yeah. So y1, so let's do 300 minus minus 0, over x2 minus x1. So 0 minus 3. What's 300 minus 0? What's 0 minus 3? Negative 3. What's 300 divided by negative 3?
-1.
Negative 100. So my slope, m, equals negative 100. So I can now write my equation, f of x equals, now in their case, they put the y-intercept first, the 350. So we can do that. So we can say 300 minus 100x.
Wait. Oh, wait.
But you could also write it the other way around where the x stuff is first. I just wrote it the same way that they did so we can compare. So now we know that where we ended up and how fast we were going for our other equation. Let's see how they said to do it. Oh, they did an input-output table.
Ooh, no.
Okay, so if we're going to graph their equation was what? 350 minus 125x, right? So where is my y-intercept? If I were to rearrange that, I would have f of x equals minus 125x plus 350, right? Right? So my y-intercept is, so up here I would click 350. And what's my slope?
Something.
Down 125. So you see down here it went about 125 down. They put the next dot. Okay. The other way you can do that is, if you don't want to do the slope because it's such a big number, you could put a 0 for the y value and solve for x. Let me show that. So if I have the equation f of x or y equals 350 minus 125x, and I want to find where it crosses the x line, meaning I want the x-intercept, we plug a 0 where the y is. Now can I solve for x? Yeah. So I'm going to subtract 350 equals negative 125x. So divided by negative 125. So what's 350 divided by negative 125?
Like 475.
Should be like,
Negative 2.8.
Oh, divided by, sorry.
yeah, negative 2.8. So you see on their graph, it crosses the line at almost 3. So that would have been correct. Cool. All right, so if we compare the two graphs, the first flight took how many hours?
A couple.
3. See over here, the first flight took 3 hours to go 300. The second flight took how many hours? 2.8. So which flight was faster?
No, second one.
Second.
Oh, yeah.
Just under 3 hours instead of exactly 3 hours. Okay?
Yeah.
So you can either do this by, you can do the table if you'd rather. That's fine. You just plug it in 0, 1, 2, 3, because that's how many hours you would guesstimate. Either way works. I prefer graphing it using the slope. All right. So do number 9. And then you're done. So on this one, if you look at the first flight, it's 3 hours. So if I take this equation up top and I plug in 0 at the beginning for f of x, because that would be where it crosses the x line. So 0 equals 250 minus 75x. And so that'll give me how many the x value is for the second flight. 250 minus 75x. So I get negative 250. And I divide by negative 75. So what's negative 250 divided by 75?
3.3333333.
So 3.3 with a line over top. So which flight was faster, the first one or the second one?
First one.
First one, because this is over 3 hours, and that one was less than 3 hours.
Oh,
Or at
I
3
forgot
hours.
to put the line over.
Oh yeah, if it's a repetitive 3.
I could have done 3 1/3 also, right?
Yes, fraction's fine. Yay, so you're done.